In this video, we're going to look at the properties and reactions of group 2 metals that you need to know for OCR A-level chemistry. This is a revision video. For more detailed explanations about the content covered, please check the links in the description below. The first ionization energy of the group 2 metals decreases down the group. This tells us that it gets easier to remove an electron from an atom of each metal as you go down the group. This is because there are more inner electron shells, meaning an increased level of inner electron shielding. The outermost electrons have less attraction to the positively charged nucleus, and it is therefore easier to remove them from the atom, meaning first ionization energy decreases down the group. The second ionization energy of the group 2 metals also decreases down the group, for the same reasons as for first ionization energy. The atoms get larger and there is more inner electron shielding, meaning outermost electrons are held less tightly. The second ionization energy for each metal is higher than its first ionization energy, however, as a negatively charged electron is being removed from a positively charged ion, meaning more energy is required to remove it. Reactivity of the group 2 metals increases down the group. When the metals react, they lose their outermost electrons, forming positively charged ions. They form ions with a 2+ charge as they lose their 2 outermost electrons from a full S subshell. This trend in reactivity can be seen by looking at the reactions of the group 2 metals with water. When a group 2 metal reacts with water, a metal hydroxide and hydrogen gas gets formed. The general reaction is metal plus water forms metal hydroxide, MOH2 plus hydrogen gas. Magnesium reacts very slowly with cold water to form magnesium hydroxide. The reaction is slow due to insoluble magnesium hydroxide being formed, inhibiting water from reaching the solid magnesium. Magnesium reacts quickly with steam to form magnesium oxide, MgO. Calcium reacts steadily with cold water. Strontium reacts quickly with cold water, and barium reacts rapidly with cold water. The reactions become increasingly vigorous as you go down the group, showing an increase in the reactivities of the metals. Group 2 metals react with oxygen to form group 2 metal oxides, with a general reaction of metal plus oxygen to metal oxide. 2M plus O2 forms 2MO. The reactions are vigorous when the metal is heated in oxygen. For example, magnesium burns in oxygen with a bright and white flame. Group 2 metals react with dilute hydrochloric acid to form metal chloride salts and hydrogen gas, with a general reaction of metal plus hydrochloric acid to metal chloride and hydrogen. M plus 2HCl forms MCl2 plus H2. Again, as the group 2 metals become more reactive as you go down the group, the metals react more vigorously and hydrogen gas gets produced at a faster rate. Group 2 metals react with dilute sulfuric acid to form metal sulfate salts and hydrogen gas, with a general reaction of metal plus sulfuric acid to metal sulfate and hydrogen. M plus H2SO4 forms MSO4 plus H2. Group 2 metal oxides react with water to form metal hydroxides and an alkaline solution, with a general reaction of metal oxide plus water to metal hydroxide. MO plus H2O forms MOH2. The reactions get more vigorous as you go down the group, and the solubility of the metal hydroxide formed increases, meaning the solutions become more alkaline, as more hydroxide OH- ions are present in the solution. Apart from beryllium oxide BeO, the group 2 metal oxides are basic. Beryllium oxide is amphoteric. It can react with both acids and bases. Magnesium oxide MgO reacts with water to form a weakly alkaline solution with a pH of approximately 9. Calcium oxide, CaO, reacts quickly with water, producing a solution with a pH of approximately 12. Strontium oxide, SRO, and barium oxide, BaO, react vigorously with water and produce highly alkaline solutions with very high pHs. The basic nature of group 2 metal compounds gives them many uses. For example, magnesium hydroxide, MgOH2, and calcium carbonate, CaCO3, are used in medicine to help neutralize excess stomach acid and raise the pH slightly in a person's stomach. Calcium hydroxide, CaOH2, is also used in a similar way in agriculture to raise the pH of soils that are too acidic.